With views, no data is stored permanently. Every time you access the view, the underlying query is run. Materialized views, however, do support physically storing the data from the query. A materialized view caches the results of the query and then supports refreshing or updating that cache manually. When you mark a view as materialized, it will refresh its view of the data only when you issue the refresh command. So one common use case for materialized views is when the underlying view query is quite complex and expensive to run, and you don't always need the most up-to-date data. For example, you might create a materialized view to return the data to display on an analytics dashboard. It might be okay for your use case that the dashboard only refreshes hourly or daily. If you didn't have a materialized view to cache the results, every refresh or every time you loaded that dashboard, it would cause an expensive and slow query to run. So the upside is that you're not wasting resources running complex queries repeatedly, and the downside is that you might not have the most up-to-date data when you access the view. Even though materialized views aren't part of ANSI SQL, most database engines provide a way to implement something like materialized views. Let's dive in now and take a look at an example. I'm going to start things off by pasting in a query which is fairly expensive to run. What this query does is present for each customer an array of their different rentals. It uses a function called array_aggregate. You might not have seen this function before, but it's just another aggregate function like sum, count, or average, except it aggregates the values into an array type. Let's run this query now and have a look at some of the results. So for each customer, we're presented with an array of their different rental IDs. I ran this query on a really powerful desktop computer, but even then you would have noticed that it took a couple of seconds to complete. If you run this query on a slower machine, you'll find it will take even longer. So we've got our expensive and slow query. Now let's save this as a materialized view. It's very similar to creating a regular view, except we simply write create materialized view this time. And I'll indent the query itself, running this. So I've just created the materialized view and it has cached the results of that query in the same step. Let's now just run a select statement against that view. Notice how when I ran that select statement, the results were instant. That's because it's no longer running that complex query. Instead, it just read the rows from the cache, which in essence is just a table stored on disk. However, we've got the downside that if there are now new rentals or new customers that get inserted, or any other modifications are made, they won't show up when we query the view until we refresh it. To demonstrate that, what I'll do now is create a new customer. So I'll create this new customer within a transaction block so I can roll back the new customer addition after I'm done. I don't want to make any permanent changes for this demonstration. So I'll issue a begin command. Now I'll insert a new customer and I'll just paste in the insert statement for that. Now let's access that view again. So let's run this select query. Notice that there's still only 599 customers in the output, same as before. So this materialized view is now out of sync with the real customer and rental tables. We can refresh the materialized view by issuing the refresh command. Run that. The underlying view query has been run again and the results have been cached. Now let's run our select statement again, and we now should have an up-to-date view of the data. Notice that we now have 600 rows in the output. There's a new customer ID, the customer ID with 601 that has no rentals, and that's the customer that I just inserted. Finally now, I'll just issue a rollback command to remove that customer that I just created. Because materialized views don't refresh automatically, in many situations, you may want to set up some sort of automatic refresh policy. One way of doing that is to use a tool called PG Agent. PgAgent is a job scheduling agent for Postgres databases, and it's capable of running multi-step batch or shell scripts and SQL tasks on complex schedules. So you could set up PgAgent to refresh any materialized views in your databases hourly, daily, weekly, whatever is appropriate for your use case. I won't be going into setting up PgAgent in this course, but if this is something you're interested in learning more about, I'll leave a link in the video description. Finally, we're all done for this demonstration, so we can drop that materialized view from our database with the drop materialized view command. And our view has now been deleted from the database.